field monitoring system. And my name is Paul Gannett. I'll be your host today. We're going to give you some general guidance to help you choose a system, no matter what brand of wireless monitoring system you're looking at. Some of what I'm going to be covering is pretty obvious, but hopefully there'll be some good points in there that you may not have thought of. And hopefully this will also provide you with an organized framework for looking at wireless field monitoring systems. Hopefully all of you are hearing me now, but this slide is a prompt in case somebody isn't. So we'll give them a moment to send me a notification if they're not. Seeing that there are no questions, I think the audio is good. I'm thankful for that. I had some audio problems earlier, but I think we've worked through those. Just want to let you know that we are recording this webinar, so the recording will be made available afterwards if you'd like to refer to it. I'll run about 45 minutes. It'll include some time for questions at the end. And I also welcome questions during the presentation. So if at any time you think of something you want to ask, if it's appropriate to cover at that point, I may just address it then, or I might save it for the question and answer section at the end. One thing I wanted to note is today's webinar is intended to be kind of generic. In other words, I'm not really specifically talking about our products. I know some of you sent us questions in advance, and thank you for sending those questions in advance. If they were product-specific questions, what we'll probably do is follow up with you afterwards and get you the answers related to our products. But today, I really want to try to keep it in terms of general guidelines and just to give you a feel for your choices without sounding like a commercial. So I'm going to keep it fairly brand agnostic. Of course, if there's time at the end and there's some specific questions on our products and I have time to answer those, I will address them then, but probably for the most part, we'll be following up with those questions. So I think many of you are familiar with Onset. We've been making data loggers since 1981. We're best known for our Hobo brand of loggers and weather stations. And they're used around the world, all sorts of extreme environments, the Arctic, deserts, a lot of harsh monitoring environments, and they're very well known for their reliability. It's given us a lot of experience working with users like you to help solve their problems, so we're leveraging some of that to share this information today. Just a little bit about me. I'll keep this part brief. I've been with Onset for 22 years. Basically, I've helped develop most of our environmental loggers for outdoor and underwater use. I do kind of the market research. The engineers do the hard work of designing the products and making them work reliably. But together we work as a team. Oops, sorry. And again, as I mentioned, a lot of experience working with researchers and growers and research agencies. And not just a little bit, is we're located here on Cape Cod, where I live as well. And the natural environment around here is real important. So, we care about the environment and monitoring it. So that's part of the reason that we do what we do. Here's our agenda for today, just to give you a brief idea of where we're going to go, starting out with an introduction, which we're basically in now. Then I'm going to talk a little bit about the benefits of using wireless field monitoring systems and just introduce a little bit of terminology so we're all on the same page. And it also gives you a little sense for how you can use these to really help do what you need to do. And then I'll get into the specifics of some factors to consider when evaluating different wireless monitoring systems. As I mentioned, there'll be some time for questions, then we'll wrap things up. So first, I'm going to start out with a question for you guys. and it's a poll question, and just gives me a sense for where you're at, so I can better speak to that. So let me call that up here. So let's see. Hopefully you're seeing a screen now that's asking what is your primary field of work. If you could click the box that's closest to what you do, that would be great. Give you a second to answer that. Oh, interesting. Okay. I'm going to close this out and let you share the results with you. Let's see. Turn on share. And about 15% of you are commercial growers. About the same percentage are doing agricultural research. A big chunk of you, almost half, are doing environmental research. And 27% are in other. Let's see. Okay. I'm reading some of the applications you're sending in now. Okay, looking at roadways, what's happening in freeze-thaw cycles. Interesting. With the federal government. Okay, good. Well, thanks. It gives me a sense for where you're at, and like I said, that will help me better tailor what I'm talking about to your fields of work. Definitely the biggest chunk is our environmental research, so that's not surprising. See, that's a big part of where we've been focusing. And so first I'll talk a little bit about the benefits of wireless sensor networks. And this is for growers. So for the 15% of you that are growers, these are some of the benefits you can achieve. Saving water, that's a big one, especially if you're in places like California. There's not enough water to go around. So you're looking to save water. You're looking to protect against climate hazards. If you're here in the Northeast where we are, a lot of growers are concerned about frost protection, or in other places they're worried about excess heat. You have to pull the workers out of the field if it gets too hot. Then many of you are concerned with protecting your crops from pests and diseases, which are triggered by climate conditions. You know, for example, if it's really high humidity or high temperatures, the chances of diseases occurring are increased, and you may need to apply pesticides to protect your crops. And the next benefit is saving costs, and that's kind of tied to the pesticide application. If you can stretch out the timing between your pesticide applications, you have the benefit of saving some money and reducing your environmental impact, which obviously we're all concerned about. And you can also save some costs in terms of the number of people you need to have out monitoring your fields, because you can use your wireless sensor networks to monitor the fields, at least some of the basic conditions. Another benefit is there's more and more regulatory restrictions that you need to comply with, especially if you're like applying pesticides. You might have to make sure that your wind conditions are below a certain level, and you want to have records of that. Another important point down below is the conditions of your fields can vary. So in many cases, you may need to monitor multiple points, hence the need for wireless sensor networks, which can monitor multiple points. Here's some of the tools available for you. If you're a grower, you can use evapotranspiration or soil moisture sensors to help manage and make your irrigation decisions, when to turn on your pumps or irrigation systems. There are many disease models which help tell you the optimal timing for when to apply your pesticides and fungicides. Dashboard views can give you a big picture of what's going on in your different fields and figure out which fields need your attention the most, as well as alarm notifications to let you know if there's critical conditions such as frost happening. You can get out there and respond. Greenhouses. I didn't see too many of you that were working in greenhouses. That's okay, but sometimes some of you that are researchers, you'll be doing research in greenhouses because that gives you a nice controlled environment. And in those cases, these are some benefits for you. But because not many of you are in greenhouses, I'm going to kind of gloss over this slide. And for all of those that are in environmental research, there's many benefits. These are just kind of the highlights. One of the key things is quite often your research sites are remote from where you're located. Having web-enabled wireless sensor networks allows you to monitor these sites even when you're not there. And another important benefit is protection against data loss. Because the data is being uploaded to the internet on a regular basis, you've got a record of your data. So should a grizzly bear or something come out and attack your weather station, you've at least got your data uploaded up until that point, so you minimize your data loss. And you can also get notifications if there's a system failure, so you can get out there and do maintenance to either replace a system that was attacked by a grizzly bear or whatever else needs to be done. And having wireless sensors give you the added benefit of you can monitor many points across your research site cost effectively, and by monitoring more points you can get a better insight into what's going on out there. So hopefully get more out of your research. Just a little bit of terminology. Is there a difference between wireless weather stations and wireless sensor networks? And yes, you probably figured that out. Let me just talk a little bit about kind of how I'm defining them. A wireless weather station has wired sensors into a station, and each station has its own cellular transmission and data plan. And these are great for monitoring weather conditions in a particular site. So for example, if you just need evapotranspiration at a particular site, a wireless weather station may be the perfect way to get that information. On the other hand, wireless sensor networks use a central station with a cellular transmitter, and then the wireless sensors communicate back to that station, either in a mesh network or a star network. We'll talk about those in a minute. And you can also have wired sensors at the central station. So this gives you basically coverage to monitor more points. Just pausing for a second to look at the questions. Yeah, okay, yeah, there's some good questions. I'll address these as we go. Yeah, there was one that was talking about doing research in a greenhouse, which kind of ties in with what I was saying, that it is quite common to do research in a greenhouse to supplement your outdoor research. This particular researcher is doing research with LED lighting. A lot going on there. So back to what I was saying about wireless stations versus wireless sensor networks. One of the things to keep in mind is a wireless sensor network can reduce your data plan costs by reducing the number of data plans you have to buy or subscribe to. So just using a simple example, if you needed to monitor 4 different locations over 5 years, if you were to have 4 wireless weather stations, I show that on the left, that would be $4,000 over those 5 years. On the other hand, if you're using a wireless sensor network, and the sensors and the stations are close enough that you can have them all communicating back to the same web-enabled station, you only need 1 data plan. That's $200 a year over 5 years. That's $1,000. So you can save $3,000 bucks. So it could be substantial. But you may be able to use a single weather station. In the top case, if your fields look like that field, where just big flat area, pretty much the same conditions, uniform soil conditions across that area, 1 wireless weather station may be all you need, because the weather at one end of the field is the same as the weather at the other end of the field. So that's the one case. On the other hand, if you get a situation more like the bottom picture, where you've got some hills, you might have some bodies of water, you got variations in soil types. In these cases, you're more likely to need a wireless sensor network so that you can monitor the different zones. So you can have sensors in each of those different zones. So now, using those definitions, let me ask you where your experience is. So this is our second poll. Let me call that up. Hold on. Let me just get your sense. So basically, yep, there we go. So if you've used wireless sensor networks or wireless weather stations, please click the appropriate box, or if you use both or you haven't used either. Let's see, how's it looking? Okay. Okay, good. I'm going to give me another second. Here's the results. And the winner is, most of you haven't used wireless sensor networks or weather stations yet. So you're at the right place. This webinar is for you. So glad to have you here, and hopefully we can help make it easier for you to get into the wireless monitoring area. So good, thanks. So with that bit of background, let's get into 6 factors to consider when choosing a wireless field monitoring system. So we'll just kind of go through these in order. And again, this is not covering everything you need to look at, but these are kind of the prime categories, and we can talk about some of the other things later. Let's jump right in. So ease of deployment. One of the factors to look at relative to deployment ease is how do the wireless sensors link into the central station. And here's some of the methods that are used. You can use the push of a button. Some of you may have wireless routers in your house that use that method, where you push a button on your wireless device and on the router, and that puts them both into a join mode and links them up. So same thing here with wireless sensors. Some systems have that option. Others have apps on mobile devices that allow you to configure the wireless sensors with those. Some older ones have what's called dip switches. These are little address switches that you set on each of the modes and on the central station to, I guess, if you've got a garage door opener, you might have dip switches to link your module in your car to the garage door opener in your garage. So same sort of thing there. That's another way of doing it. And some systems you have to program in addresses. That's a little more difficult. So you probably want to look for systems in the top 2 categories if you can. Another factor in ease of deployment is mounting. Generally, the smaller the wireless transmitters are, the easier they are to mount. And you want to look for ones that have integrated mounting provisions. I love being able to mount things with zip ties because they're just so easy to carry around and install. And if you need to move them, you cut them off. So that's one of the things that I often look for when deploying field equipment. Another factor is the solar panel integrated into the transmitter. A lot of the transmitters are solar powered these days to keep the so you're not having to change batteries as often. It makes it a lot easier if the solar panel is integrated, so you're not having to monitor a separate solar panel. And another factor, and this is actually a question that one of you guys sent in advance, is about security. And that is a big concern that we hear is security. And if it's a smaller device, it makes it a lot easier to hide and put out of the way. or it also makes it easier to put in some sort of protective enclosure, like a 4-inch PVC pipe. It's a good way to hide things and protect them, and the wireless will still go through a PVC pipe. In the case if it's inside of an enclosure like that, you'll need to look for wireless sensors that are battery powered, that don't require solar power. So that's another thing to consider. And there are battery powered ones available. So let me just pause for a second here. I think I may have lost some of my screen or question. So, okay, no, I'm good. Sorry for that. Another factor in ease of deployment is software. It's the front panel for most devices these days. You want to look for software that's easy for configuring and viewing. The configuring part is configuring the modules for deployment, and then also viewing conditions, things like wireless signal strength, so you can position the modules or the transmitters more easily and for the best, most reliable transmission. You also want to look for ones that are easy to configure in terms of setting up things like dashboards, like I showed down here in the lower left. You want to look for software that can run on whatever devices you're using. Seems like we're using our mobile devices more and more, so you probably want to look for devices that can, or software that can run on your mobile devices and still look good. Not really software that's designed to work on mobile devices. And you want, as I mentioned, to be able to configure dashboards. And a lot of you, especially if you're in research, you may want to be sharing data with other users. So you want to make that easy to set up. You want to be able to allow users to either view your data, sometimes that's called a public access feature, just to share dashboards that you set up, ability for others to export data sets from your stations, pick a date range and sensors that they're interested in and export that data. Automated sending of data through FTP or email, another feature you may want to look for. And web services. This is for your more advanced applications if you're trying to build it into a program. You may not quite be there yet. So the next category to consider when looking at wireless sensor networks is the coverage, and basically, can you cover the entire research site or your fields with a wireless sensor network? Do they have enough range? And let me talk first about frequency. We found, actually the hard way, we initially, in our first generation of wireless sensors, we used 2.4 gigahertz. We found out the hard way that that doesn't work as well in vegetation. When the crops grow up to a certain point, the leaves get in the way, and that 2.4 gigahertz signal range gets reduced dramatically. So for our more recent generation products, we switched to 900 megahertz wireless sensors, and those do much better in vegetation. They'll get attenuated some as well, but not nearly as much. And then that gets into the next category, which is you definitely want to be comparing or looking at the line of sight wireless range for the sensors that you're looking at. Are they going to be able to get the data back to the central station? And usually the range is specified as line of sight range. Now, in the real world, you might not be able to get that unless you've got nice flat fields. But the reason that most vendors use line of sight range is at least gives you a way of comparing one wireless transmitter to another, assuming that the vendors are both being equally honest with their ranges. It gives you a way of directly comparing their range and coverage. And then on top of that, then if you've got trees or plants in the way, you may have to derate that range somewhat to account for those. And if you're going through woods, that could significantly reduce your range, by a third even. So keep that in mind as well. And usually your vendors will be able to give you some sense for what the reduction will be. And then you want to look at, again, the frequency. 2.4 gigahertz signals will get attenuated much more than 900 megahertz signals. And actually, this ties into one of the questions that came in as we've been talking, is how many sensors can be used with a wireless transmitter. It really depends upon, the network that you're looking at, and that's something you want to look at. Some networks are limited on the order of maybe 16 wireless sensors. I know our wireless sensor network can handle 50 wireless sensors, so that kind of gives you a sense of the range. There may be ones that allow even more, but typically between 15 to 50 is a range that you can expect. There might be some that I've seen that only can allow 8 wireless sensors, but that gives you a sense. Then we'll talk about star networks versus mesh networks. In a star network, all of the wireless sensors have to communicate directly back to the central station. And that central station will have the cellular communications up to the internet. So you're limited by the range of one wireless sensor, basically. All have to be within that radius from the central station. On the other hand, mesh networks, the sensors can communicate through each other to get back to the central station. So as you can see here, you can transmit it from much further away because it can relay through. And in here, I saw a question come in about booster stations. Typically, what you do is you have repeater stations that can be added in here. So in a true mesh network, the sensors can act as repeaters, and you can have basically standalone repeaters which don't have any sensors, which can be added. And one of the specs you want to be looking for here is the number of hops that you can go through. So, for example, in this case, if you start with the sensors that are over on the right, they have to go through 1, 2, 3 hops to get back to the central station. So, so look for that as a spec, because that'll tell you the maximum distance you can go. It's basically the range between wireless sensors times the number of hops that they can do. Hopefully that makes sense. So next thing to be looking for in wireless sensor networks, especially if you're a grower, you want to look for actionable information. And in this case, here's some features to look for. Dashboards, which show the most critical information. So you can see the current conditions at many locations around your site. So you can see if there's cold spots, hot spots. Just gives you a better feel for what's going on. You also probably want to look for a dashboard that could show just the critical parameters you're interested in. If you're just interested in temperature at 10 of your fields, for example, or 10 locations, you want to look for a dashboard that can show those 10 temperatures all together on the same widget, is what they're commonly called on a dashboard. So you look for a kind of a dashboard widget which has a table view in it to show all 10 of those. Another factor that you may want to look for, this is again kind of grower oriented, is integrated models for the kind of decisions you're trying to make. ET, which is evapotranspiration. And actually, I hear a fair number of you that are in research are looking at evapotranspiration as well. If you're trying to do water budgets for a research site, a lot of times you want to look at evapotranspiration. The ETO is the reference evapotranspiration, and ETC is for a specific crop. Another thing you may want to look at is growing degree days, which can be an indication of growth stage, when you can expect insects to emerge or plants to bloom, those kind of things. And then disease models. I show a kind of a typical disease model in the lower right corner there. And they'll typically tell you when the risk of disease is high. So when you're in a red zone that's a time when you might need to spray because there's a high risk of disease. And or, green might say, okay, you're okay. So disease models can be very helpful. And a lot of these networks that are coming out, and we're seeing more and more of these networks where they have basically bring in data from weather stations, such as from ours or others, and they can process that data through these disease models, which I just talked about, or do the evapotranspiration, and just help growers make decisions. So that disease model I show you on the right is from NUA, which is a network that's in kind of the Northeast here. I think it covers 16 or 18 states in the Northeast that are part of this, and it provides things such as apple disease models to help growers in those areas, make their crop management decisions. And you can either access the data through their network of other stations, or you can have a station installed on your site that so you can get very site-specific disease models and to help make your decisions. UC Davis, Simis, which is also in California, Weather Underground. That's not so much for crop management decisions, but it's a popular weather display interface. Another factor you want to look at in wireless sensor networks is alarm notifications. And these are important for both growers and for researchers, and I'll talk a little bit about why. One of the features you want to look for is the ability to change those alarm thresholds remotely. For example, if you're looking at frost alarms, your temperature threshold is going to be dependent upon the growth stage. So early in the season, the plants will be able to tolerate lower temperatures, so you might have a threshold at 30 degrees. And then later in the season, their temperature threshold may be higher, so you might want to set your threshold at 37 degrees. So you want to be able to do that remotely through your web interface. And it's also handy to have different levels of alarms. You might get an alarm to notify the guys in the field to go check something out at one level, but if the temperature gets above that or below that, you can notify the manager. You might want to know at that point. Another factor is in-station alarms versus web-based alarms. And in-station alarms are basically, it's checking the alarms. Every time the station takes a new reading, or the sensors take new readings, it's checking those alarms there in the field and can make an immediate connection to the web to let you know that you're in an alarm condition. And that'll give you the fastest alarm response. And there's also web-based alarms, which have to wait for the data to be uploaded. So if you're only uploading the data every hour, it could take as long as an hour for it to detect that your fields are in an alarm condition. So that's an important capability to look for if you're looking for fast alarm response. Another thing you might want to look for in your wireless weather networks is if you need to turn anything on or off. Again, this is kind of more grower specific. We have a lot of cranberry growers around here, and when the temperatures go below a certain point, they want to turn on their irrigation systems to protect their crops with a little coating of ice. And so they want that to happen automatically before they have time to they get there with their truck. They'll still probably drive out with their truck just to make sure things are going okay, but it's nice to know that have a system that can turn on those sprinklers automatically. And so for that, you want to have a system that has relay output options. If you're using relays to turn devices on and off, you probably want to look for one that has hysteresis so that you're not getting what we call short cycling, where it's turning the device on and off real quickly, because that can cause excess wear and tear on the system. So, actually, I didn't mention it here, but I think maybe I mentioned it later on. But for those of you that are in research, alarm notifications are valuable because you can use the alarms to tell you if there's a system problem, if there's the wires are cut, system's damaged. A lot of systems have the capability to send you basically what's called a system alarm. There's a problem in your system, and those can tell you even if the system's not able to communicate, it can generate an alarm. That's like we call those missed connection alarms. And so if that's important to you, look for a system that has that, and that can give you a notification that there's a problem, so you can get out there and repair the system so that you don't miss critical data. So, even if you're a researcher, it's nice to have alarm notifications. It can also tell you if critical conditions are reached where you want to go out and make some field observations. So, data storage. This is, again, especially important if you're in research, because you want to have complete history of the data that's out there, and so that you can really, correlate the conditions with, growth or water use or whatever you're studying. You really need to have that complete record of the historical data. So in this case, you want to have some redundancy of data storage. And the reason for that is with wireless and with cellular, there are going to be times where communication is interrupted and you don't want to miss the data during that time. So if the wireless communications between sensors is interrupted, you need to have wireless nodes that have data storage in them so that they can store the data during that wireless interruption. And then when the communications is restored, that the data gets pumped up to the central station where it can be transmitted to the web. So look for wireless nodes that can store the data. The same thing with the gateway station, the central station that transmits to the internet. We all know that there's times when cellular communications gets interrupted. So you need a station that can tolerate that, and most stations do. They'll have some memory in the central station, and once communications, the cellular network's going again, it can upload the data to the web where you could access it and get that data, so you don't miss any data. Then the other side of it is you want a reliable website for hosting your data, one that's got data backup, so that if for some reason there's a failure at one site, you really want to have a web hosting service that has backups, so that in case one site goes down, you can still get your data from another site. And that's really kind of up to the service provider that you're working with to make sure that they've got redundant website hosting to protect against failures there. And also make sure that, I think maybe I have a bullet, I don't, make sure that they will retain your data. Some web services will retain your data for like a year, but then you got to pay extra to get it beyond that. So make sure that you know what the policy is with who you're working with, and if you're looking for long-term data storage, make sure that comes with the service level that you purchased. So, and for those of you who are growers, even if you don't think you need the historical data, you're just using the data to make your current decisions, you might want to downstream. You might want to look at it for comparing your yields versus weather conditions. You might find it interesting to know what the history was, and it might also provide some protection against future claims. If somebody says that your pesticide or weed killer carried over onto their field, you can look at your wind data when you applied that weed killer and say, hey, it was only blowing 1 mile an hour. It shouldn't have carried that far, or whatever. It's good to have that data. So another factor, this is one that I guess probably everybody knows, is when you're comparing different systems, is you want to look at the cost. Before getting into the details of areas to look at, I just wanted to kind of frame the discussion. You think of the cost of a system as an investment. This is hopefully going to protect your crops, protect your research, allow you to do better research. Look at it as an investment rather than just a cost. And look at it over some sort of planning horizon, such as over 5 years. Maybe it's a typical planning horizon if you're a grower. And so you want to look at the total cost over those times. And if you're a grower, check to see if there's any grants or subsidies available. A lot of times there will be grants made available to growers. For example, if there's a region where they're looking to save water usage, there might be grants available for systems that can help save water. So look for those. That can help cover the cost. So now let's get into some of the costs to consider. Of course, there's the initial upfront cost, cost to purchase the systems and the sensors, all of that. But there's also the installation cost. Now that installation cost can take the form of you hire somebody to do it, or maybe it's included in the cost of your equipment purchase, or it could be the cost of your time and your labor to put that system in. So make sure to factor that in. Then you want to look at the annual cost, because there will be some ongoing costs. So think about these as well. Most cellular-enabled systems have ongoing web hosting service plans, which you have to pay for. A typical cost for those might be $200 per year. If you're in a place where you can get Wi-Fi or Ethernet connectivity to your station, you might be able to get a free service plan, so those can save you some money. Another thing to watch out for, to look for, is if your provider is going to charge extra per node or per sensor, or additional for software features. So make sure that you've asked about those additional costs for features and sensors that you might need to pay for as well. Or for data archival. Some of them, you get the first year of data storage free, then you got to pay for it after that. And let's see. Then the other cost model that some is an option through some vendors is leasing. So rather than buying the stuff up front, you just pay for an annual leasing cost, and that's a way of spreading out your costs. So that's an option as well. Then beyond the annual kind of dollar costs, you need to factor in the maintenance costs. So it's a good idea to get out and check your systems at least once a year, make sure that sensors are still accurate and reporting reliably. If you need to replace sensors, it's nice to have a system which you can replace just the sensors that you need to replace, rather than having to replace the whole system. So look for that kind of modular serviceability. And another factor to look for is the durability of the sensors themselves. If you're going to be using it for 5 years, you want to look for a system that offers sensors that are going to last for a full 5 years or more. Another cost to consider is ability to expand the system in the future. Is the system going to allow you to add to it in the future, or are you going to have to buy a whole new system? So consider that as well. Sorry, I'm just pausing. I was reading a message. Okay. So that actually is the 6 factors that I wanted to cover formally, and but I know there's other factors as well. But let me just kind of review what we've covered. You want to look at the ease of deployment. You want to look at the wireless sensor coverage. Is it going to be able to cover the area you need to monitor? Does it provide you actionable information? Does it provide you alarm notifications? Those are really, really helpful. Does it protect and provide historical data that you need? And look at the cost, of course. So at this point, this is a chance for you to just kind of ask about other factors that you've thought about. And maybe we can discuss those, share those amongst ourselves. Actually, I got a question here about operating in extreme temperatures. Some of you might be operating in the Arctics or in desert areas. One thing to look for is the rated temperature range of the sensors you're looking at, and sometimes they'll have multiple battery options. Typically, rechargeable batteries they can cover a range of maybe minus 10 degrees to 140 degrees Fahrenheit, whereas lithium batteries, they're not rechargeable, but they can give you a wider temperature operating range, maybe down to minus 40 degrees Fahrenheit and up to 160 degrees Fahrenheit. So, look at the battery options if you're in those kind of extreme environments. Other questions? Remember, you can type them into that question and control panel. Here's a question. Yeah, well, it's a question about if you don't have cell coverage at a site, can you transmit into an office on the site and then transmit your data via the web? Yeah, well, there's a couple ways. If you don't have cell coverage, one is, if you can get Wi-Fi, if you're within Wi-Fi range, or Ethernet connection out to the station, you can use that. And then you can use the wireless sensors to communicate even further afield. So you definitely look to see if there's some building that has internet access, that you can get a Wi-Fi transmitter in. There is Wi-Fi extenders. So basically they're Wi-Fi transmitters that are designed to transmit longer distances. I don't remember the names of them right now, but if you are interested in extended Wi-Fi coverage, send us a quick email and we will, or enter it in as a question, and we'll follow up with you with the name of some Wi-Fi extenders that are available. Let's see. Oh, lots of questions. This is great. So I'm going to have to scroll through these. Let's see. Oh, there was a question. I mentioned that you can get service plans for Wi-Fi or Ethernet that are free, and it really depends on the vendor. What their model is for charging you. So I know for us, our Wi-Fi and Ethernet plans are free, and they'll give you up to 10-minute upload rates. That's another factor you want to look at, is how fast are the stations uploading data to the internet. That could be critical if you're looking at real-time monitoring applications where you need to know the temperatures in the field and be able to see them. You want to look for a system that can connect at a faster rate. So look into that. And as part of that, when you're looking at the connection rates, there'll be usually different levels of service plans. It might be $150 a year if it's only connecting every hour, but it might be $250 if it's connecting every 10 minutes, for example. Okay, here's a good question, and actually I thought about this afterwards. I probably should have included this. Is one of the factors you definitely want to look at for the systems is what sensors do they offer. You want to make sure that the system you're looking at provides the the sensors that you need. So some systems have integrated sensors. So in that case, it's just the sensors that they sell. Some systems have analog inputs or digital inputs on their wireless sensors, and that allows you to connect in other sensors. It might require a little bit of programming or setup to connect in those other sensors, but at least in that case, it allows you to enter in or to use those other sensors as part of the system. So yeah, definitely look for the sensors supported. There's a question about calibration. That's probably more a specific question to the brand you're looking at. But yeah, it's a good question to ask, is what calibration does your vendor recommend for calibration frequency and how to do it? You know, for example, tipping bucket rain gauges, you want to check their calibration once a year, and usually it's some sort of screw that's on the bottom of the tipping bucket rain gauge that you screw in or out to you know, kind of calibrate to make sure that it's measuring accurately. So it's usually not too bad. The toughest part is getting a reliable amount of water to run through for the calibration. Let's see. I'm just reading through the other questions. Let's see. Some of these we may want to follow up specifically with you, because they're very specific to our products. There's a question about placing wireless sensors in an orchard, your larger trees. And yeah, that's, you know, when the trees are leafed out, the wireless signal range is going to get reduced. Now, there's different ways you can manage that. If you can put the wireless transmitters high enough that they're above your trees, then you can get true line of communications, line of sight communications between the different sensors, and you can get almost the full rated range of the wireless sensors. If you're doing that, you probably want to look for sensors that you know, are small enough that you can mount them up high without having them bend and flop all over the place. And you want to make sure that the sensors have long enough wires to, let's say if you're monitoring soil moisture, you want to make sure it's got enough cable length to reach from your transmitter above your trees to the sensor that's buried down in the root zone of your soil. So look at the cable length in that case. Another way you can help with the wireless transmission range in orchards is line up the wireless sensors on, you know, in rows, so that you can do your longer distances, straight down a row, and then you can maybe have a repeater that relays the signal to some trees that are, you know, kind of cross rows. So, you know, that a little bit of mapping there. A real useful tool for looking at wireless sensor coverage is go into Google Maps, zoom in on your site, map out where the sensors can go and look at the range, and, you know, kind of starting from the central station and working your way out to make sure you're going to be able to get the wireless sensor coverage where you want it. Let's see. Yeah, some more specific ones. Sorry. Yeah, for ones that are asking about what Onset has to offer, I may address some of those at the end, but I think I'm going to run out of time for those. I think we'll follow up for those Onset specific questions afterwards. So I'm not ignoring them. We'll just follow up with you more personally. Yeah, here's a question that comes up. How well can you hide remote monitoring stations if you're using them in an urban environment? Can these be mounted up very high or within an object? Yeah, that's a common challenge, is people tampering with the system. So, yeah, in most cases you can. You can mount it up higher on a pole, so somebody would have to climb up a telephone pole or whatever to get to it. the cellular obviously is going to be good up there, and you can get good wireless sensor range if it's mounted up high. If you mount it in a plastic or a fiberglass enclosure, that can provide a degree of security. Well, the cellular signals and the wireless signals will still go through plastic and fiberglass without any problem. So definitely that's a good strategy. You can put a real robust enclosure around your wireless sensors and have a lock on it so that only you can get to it. We do have a little, and many wireless sensors do have like little security tabs on them that, you can put a small padlock on them, or a zip tie through them, but that's just to keep away the casual vandals. If you really want to protect it against the more aggressive vandalism, you probably want to put it in another secondary enclosure that's anchored down really securely. And that's a challenge. Let's see. Yeah, there's a question about resources. I'm going to get to that in a slide or two. So just hang on for a second for that, because we've got some good resources here at Onset that I want to refer you to. Yeah. Yeah, okay. If you mount the stations up high, how often do you need to access them? Typically, once you've set up one of these wireless sensor networks and a station, kind of a central station, you really don't need to get up into the station. So you can mount them in pretty hard to access places because they're solar powered, and the batteries, they eventually need to be replaced, but it might not be for 3 or 5 years before you need to replace the batteries. You'll still want to do sensor checks, to make sure that they're reporting reasonable readings. But usually you can do those even without accessing the transmitters. So, these are good questions. So I think I've covered most of the ones that are of general nature. I apologize if I've missed your specific questions. And again, we will follow up with you. Either me or somebody else here will follow up with you on your more specific questions. What I'm going to do is point you to a couple of resources that you might want to look at. One of them is that we have a white paper that basically covers the same material that I've covered here. It's a web download. So you just go to the onsetcomp.com website and look for the field monitoring guide, and that'll give you some this information in a nice written form so you can follow along. And like I said before, this webinar is being recorded, so you can refer to that recording as well. And then in general, we have a ton of information on our website. We've been doing this for a lot of years, and so we put up a lot of white papers, sharing the experience of users like yourselves in all sorts of different applications. We've got webinars, like this webinar will be posted up there as well. So, any of our webinars are up there for, product tutorials or application tutorials, some self-guided training. And if you don't find what you need on our website, Google, of course, but you can also call us up, contact our application specialist at this web address, or contact technical support. We're always happy to help. And with that, I think we just hit 3 o'clock, so 3 o'clock Eastern time. I want to thank you all for attending and your participation. Really appreciate your time, and hopefully I provided you with some information that will help you in deciding. And again, if you need any help on our end, feel free to give us a call. We'll be happy to quote and put some systems together for you. But good luck. We're here for you.